Hello and welcome to everyone. Thank you for attending today's webinar. My name is Julie Bloomquist and I'm a co-leader of the Database Administration Virtual Group. Today's session is Modernizing Your SQL Infrastructure with Intel Technologies in 2019. It's being presented by Jake Smith along with a co-presenter, Alessandro Goncalves. There's also going to be a lecture on the SQL Server migration this season, if you want to keep up with that. It's becoming end of support. I'd like to remind you that the price of the past Summit 2019 is increasing tomorrow at 11:59 UTC. If you use our code VGDISKG0E, you'll save $150 before the price bump. And we do hope to see you this year at the past Summit. And again, today's presenter is, today's session is being presented by Jake Smith. Jake has worked for over the last 20 years introducing new technologies in the server, storage, and mobility computing markets. He currently focuses on the development of non-volatile memory, NVM, virtualization, security, manageability, storage, and Intel selected solutions for data centers. Jake and his team are currently working to drive standards and interoperability of cloud computing, NVM, and storage for Intel. Thank you very much, Jake, for joining us, and please go forward with the presentation. We will be having a raffle at the end of this, so thank you for attending. Thank you to all the attendees. We will be sending out information about a raffle winner.
Thanks, Julie, and go St. Louis Blues, right? So it's an honor to be here, and it's been our pleasure. I'm joined today by Alessandro. Alessandro, welcome. Alessandro joins us from our non-volatile memory storage group, a group that I used to be a part of, and he's a collaborator with myself and with the Microsoft team on modernizing SQL infrastructure. And why is this really important for Intel? Well, the modernization opportunity for us all is really a multi-pronged approach. Ultimately, as we build digital infrastructures to support humanity, it really requires us to ensure that we have the most secure, scalable, and performance solutions available. Today, about the average life cycle of a server is over 5 years. 5 years ago, 9 million servers were sold. That means that there's an untapped trillion-dollar business potential for the industry. But for administrators who are dealing with how do they manage the data that their businesses and companies are creating, this is a slightly bigger problem. It's not about a business potential. It's about how do I modernize my infrastructure to be able to address today's business needs. So what are some of the modernization triggers that we see? We see that data center contracts expire. We see that there's integration and acquisitions. You've got multi-location issues. You have actually compatibility issues. You might have a division that has an old version of software that you need to upgrade to the new central accounting. You have capacity requirements. We see this on a pretty regular basis, that capacity is really outstripping your ability to serve your customers and your business needs. And then what we're going to talk about today is software and hardware refresh and why that's so important. Security threats are constant. They're never going away. We at Intel take security very seriously. Many of you are aware of the work that we're doing. We're going to continue to do that. We've formed a 400-person team to drive that and to continue to drive that for years to come. Compliance is a very big issue. Policy, compliance, privacy, confidentiality, these are really critical for us to do our job well. And so really when you think about how do we manage all this, you have to think about, well, we have to have a data store, we've got to have an OS, and then we have to have hardware or cloud. But in order for those to work, they have to work in conjunction and they have to work together. When we look out at what we have seen at Intel and our work that we're doing with Microsoft, we see this deadline to act before the end of support as an opportunity for us to help everyone in the industry. Many of you are running, we know, based on data that you have provided to us, that you're running 8 to 10-year-old hardware. Nehalem, which we introduced, I helped to introduce in 2009, a wonderful platform. It continues to be a large part of your estate. But as we look forward and we look beyond and we take a look at the current generation of Xeon Scalable and actually the second generation of the Xeon Scalable platform, code name Cascade Lake, we see a real opportunity for our customers, our partners, to upgrade their data infrastructures, not only to beat this deadline, but to also get the security updates that you need to meet the compliance concerns that you may have and take advantage of the innovation that we've built on the platform. And Alessandro and I will talk about that innovation with our 2019 technologies that we're so very proud of at Intel. So you really have a couple of options, and I do want to give credit to my friends at on the Microsoft team and Ramnik Golati, who I worked with on the last iPass marathon. We wanted to try to provide as many modernization options for customers as possible. You can obviously modernize to Azure. It's really a lift and shift to a platform as a service infrastructure for Azure SQL database managed instance, or you can modernize on premise, right? And the path to modernization, we'll talk about some of the hardware paths to modernization and how you can deliver the ROI to the business leaders in your organization to show them the flexibility, capabilities, and opportunities that the new platform creates. Alessandro, is there anything else that you'd like to add?
No, that's basically Jake. We are working closely with Microsoft in order to ensure that we deliver the best experience to any charge that the customer might have.
And it's really about providing the value of refresh. And Alessandro pointed to the customer obsession that we have at Intel. It's really a mantra. It's a cultural addiction that our CEO, Bob Swan, has instilled in us or is trying to instill in us. And it really is about ensuring that each and every cycle, when we deliver a second generation Xeon Scalable platform and then a third generation Xeon Scalable platform next year, that we're able to provide a 5-year refresh and value of refresh very consistent with your expectations that you've had since we launched Nehalem. The expectations of IT leaders when buying Intel is that we're delivering multiple exponential returns on investment, and now you see the value of refresh. When we take a look at the enterprise IT OLTP database, we see a 3.77x return. On cloud infrastructure and VM density alone, we see in our baseline that our lawyers allow us to quote 3.52. Many of you, as you deploy the new architectures, will take advantage of 28 core and above 24 core, 28 core, 16 core solutions that will even deliver better VM density than predicted, because your current infrastructures are on maybe 4 or 8 core and maybe on a different core, and not all cores that we've developed over the years are created equal. The other thing that you get with the second generation Xeon Scalable architecture that you didn't get in the past is you get a full integration stack with NSG. And Alessandro and his team work not only closely with Microsoft, but they work very closely to integrate their firmware and drivers and optimize those to take advantage of Intel second generation Xeon Scalable solutions. So let's talk about a mantra that you're going to hear from Intel, and I want to try to make sense of it all. I've brought my partner in the store more business, and Alessandro, I want you to talk about Optane in a minute. But we're really going to continue to talk about three key areas as you modernize your infrastructure. Move faster will be a discussion about our Ethernet, silicon photonics, and OmniPath fabric technologies. Store more will be a deep dive into Optane, and process everything will be a closer look at what we're doing not only in CPU or central processing unit technologies, but also the work that we're doing in FPGAs and the work that we're doing in GPUs and the work that we're doing in visual processing units with our business unit and our technology called Movidius. But before I go too deep there, Alessandro, can you talk about the work that we've done with Optane to software and system level optimize SQL solutions?
Sure, Jake. As you know, Optane comes from a long-running research with Intel on the 3D cross-point media. And we want to bring the storage piece closer to the CPU so we could process and move faster with data across all the subsystems. And SQL is a great value for that because we process a lot of data and we ingest data from anywhere today with data lakes. So Optane, we have two flavors, which is the Optane DC SSD, which is a regular NVMe drive and can be used on basically any system that has a PCI bus. And our Optane DC persistent memory, which is an evolution of the NVMe drive that we pack a high density block storage in a DIMM form factor. So this is a groundbreaking. So we're first to offer that, where we have high density memory that we can use as regular memory or as a persistent memory or block storage. So we give customers a choice, and actually we can mix those things together. But not only that, we have to work closely with our partners at Microsoft in order to make sure SQL can take advantage of all those new innovations that we do on the hardware. And that comes with our PMDK that we call Persistent Memory Development Kit, which we make sure that the best practices to use persistent memory and to use the Optane technology are integrated into the code. So throughout the evolution of persistent memory, you're going to see more and more use cases in order to take advantage of that. But Microsoft and Intel are really tied up together in order to deliver the first full stack to the market using persistent memory.
Well, and Alessandro, you and I have worked on Optane for many, many years. And so I don't know that the audience is familiar with the endurance characteristics of Optane. So can you talk about not only endurance, but capacity? You did talk about latency characteristics, but let's talk about what this means for new data stores or the data stores of the future.
Sure. So for our solid state drive on Optane, we have a groundbreaking endurance. So if we talk about drive writes per day, which is a common denomination for SSDs, we are about 60 drives writes per day. But what that gives you is that you don't have to oversubscribe, meaning you don't have to buy more capacity that you need in order to meet your throughput and your write pressure. That same characteristic goes to the persistent memory part. So our DIMMs are 128 to 512 gigabytes of size. And with that high endurance, they can really take the workload as a memory and overwrite over and over again without having to worry about any kind of end of life. So we will support your device throughout your workload characteristics. So this is a groundbreaking across the industry. Our closest SSD on our portfolio is about 5 drive writes per day, which gives us a really big advantage on that, on top of the latency that you mentioned, Jake.
And so it really provides our data scientists, database administrators, system administrators, cloud architects, systems architects, data center architects, an opportunity to rethink the data center, rethink the latency characteristics. Remember, there are no, in all of our Optane technologies, there are no moving parts. So it gives us the flexibility, and you the flexibility, to start thinking about new usage models for data stores. All of these are optimized, working side by side with our partners at Microsoft. And specifically the team in the SQL division. And without our Microsoft Technology Center, led by Andy Vargas and Ken Rule, I don't think we would be where we are today. So really, what we're announcing today, and that we have begun to leak to the press, and what we want to continue to talk about to past members, is really 7 groundbreaking new products. Right, from the Intel Ethernet 800 series that supports RDMA for a next generation deployment, particularly with Windows Azure Stack HCI, Intel Optane Data Center Persistent Memory that Alessandro referred to, a new dual port Intel Optane Data Center SSD for greater reliability for those of you who want to build old school SCSI-like SAS reliability, SCSI and SAS-like reliability into your infrastructure. 2nd generation Intel Xeon Scalable Processors, up to 56 cores. Really excited about our Intel Xeon D1600, which will become the flagship of our edge computing infrastructure. And continue to be excited about our work in the FPGA space as we look to introduce Agilex. But the area that I want to talk to data scientists about, and that I felt very, very compelled to bring Alessandro here today, was this QLC 3D NAND SSD and the work that we've done with Ruler to define the standard. Many of you don't know that back in 2010 and 11 and 12, the industry had to define a standard for persistent memory. And Alessandro referred to the PMDK, which is our Persistent Memory Development Kit. But that's a genesis of a lot of standards bodies work that we did through the Storage and Networking Industry Association, led by my colleague Jim Pappas. And the reason that we began that work to create an open infrastructure is the same reason that we're excited to introduce this QLC 3D NAND SSD for a new form factor, codename EDSFF. Formerly known as EDSFF as a standard, but codenamed Ruler. And Alessandro, do you want to talk about what this really means for data scientists long term as we start thinking about storage and storage architectures and data stores?
Sure. Yeah, like you mentioned, we are creating and storing data in a way that we never done before. And as long as we create, we have new ways to analyze data. So we cannot afford to delete data. So we just store. So our density is key in order to store that much data without growing our footprint. That's what Ruler comes about. So a single Ruler today can store up to 15 terabytes of store, and we're coming with a 32 terabyte Ruler soon. That means that on one new server optimized for Ruler, we can have up to a petabyte of data on one new server form factor. So imagine that amount of data available to you, data scientists, in order to analyze and get more and more insights within that. So that's why we need our whole Intel portfolio, like our Ethernet series, in order to push data across the pipe, the DC persistent memory, in order to get your most needed data closer to the CPU, in order to have that insights, along with Xeon Scalable and our FPGA. So everything on a data center portfolio comes together in order to give you the ability to get data insights faster and faster. So that's what KLC 3 then comes into place, where you can store data in a very big density.
And it really changes the game. And we believe it does. It's something that is near and dear. The great architect Mike Nelson, who helped us develop Ruler, and I would say is the godfather of the technology within Intel, continues to be a close colleague to Alessandro and myself as we look to new ways. We're headed into the zettabyte revolution, team, and by 2025, my colleague Ramnik predicted at Microsoft that it's 163 zettabytes of data globally. IDC is calling it 175 zettabytes. So we're headed into a different world in terms of how we manage, store, I like to say lift, sift, and shift data. And that makes us as data scientists required to think differently. So let's talk about the second generation Intel Xeon Scalable Processor, codenamed Cascade Lake. You know, we've got over 50 standard SKUs available in the industry. Why are we so excited? Because this one is an architecture we have been developing very, very closely with Microsoft and the SQL team to ensure performance. We've got dozens of customized SKUs. You can have from 8 cores to 56 cores per socket. You can have up to 4.5 terabytes of memory per socket. And you have socket flexibility, depending on your data store, your workload, from 1 to 8 sockets. It's a kind of flexibility that's never been delivered in an architecture before, and we can't be more proud of the work that we've done here. The best part about it is we're delivering the performance that you've come to expect from Intel, and we really are customer obsessed. We've got another generation. We had a generation last year, our first generation of Intel Xeon Scalable, and we've got a second generation this year, and we're excited about the introduction of Intel Optane Data Center Persistent Memory, codename Apache Pass. It has been, as Alessandro pointed out, a breakthrough innovation. The performance that we see with SQL, as we will show you momentarily, is in my 25 years in the industry, it's really one of the most impressive things that I've ever been a part of. And Alessandro will go into more detail. We've introduced a capability called Intel Deep Learning Boost. It's a neural network capability, formerly known as VNNI to some people. DL Boost allows for us to continue our leadership in artificial intelligence and analytics, working very closely with the SQL team. They can take advantage of that for deep learning capabilities. We introduce Intel Speed Select technology to allow you to move the number of cores utilized up and down based upon the processor purchased. We've got network optimized SKUs as you look to put databases in the network, I believe a requirement. This becomes an opportunity for you to think about that. Of course, we have cloud optimized SKUs, and then we introduced new security mitigations in the new Cascade Lake platform to really focus on the concerns that we've had over previous generations and anything related to Spectre and Meltdown. So this commitment is really building on 20 years of data center processor innovation. I'm very proud to say that in 1996, I was able to be a part of the team that was able to build one of the first Pentium Pro Intel servers that later became Xeon. And the innovations that we started there have been surpassed in this platform. We never thought we'd have 4.5 terabytes of memory per socket, and we certainly are several years ahead of our per core socket count. But that's a forecast that we'll let Bob Swan share with the rest of the industry. And so as we look to thinking about modernizing infrastructure, we say, well, what are the world record performances? So we know we can run SQL because Microsoft and Intel have a very close relationship. Well, we can't just run SQL. We can run SQL, we can run Azure Stack, and we'll get into the select solutions that we've optimized, a whole host of Microsoft solutions that are really the baseline for many of these other business analytics, in-memory database, cloud management software solutions delivering 2x performance over the previous generation, and able to deliver and introduce an entirely new platinum product line called the Intel Xeon Platinum 9200 processor product line that has up to 56 cores per socket. So when you start talking about 112 cores and terabytes of memory per node, start to become very interesting use cases and business models for us to begin to think about modernizing. Now, why is modernization so critical in an era that has to manage 150 plus zettabytes in less than 5 years? Because memory is a hot tier. We're optimized to work with the best memory vendors in the world. We work very closely with Samsung. We work very closely with Micron. We work very closely with SK Hynix, Toshiba, and others. Memory is important, but persistent memory provides an incredible opportunity to change the way files interface with memory. And so we created the persistent memory file system standard and the PMDK to enable the industry and enable you to create, in some cases, higher performance solutions because it removes some of the, we'll just say, non-important processes. It has a direct access. And then we've also optimized around SSD. But as you think of the bigger iceberg that is data, really you have to start thinking about a hierarchy, not only in how you look at your server, not only at how you look at your storage area network, but how you look at where you want to move your data and your data stores in SQL into the future. So Alessandro, you want to delve a little bit deeper into our thinking around the memory and storage hierarchy in data analytics and artificial intelligence?
Sure, Jake. Like you can see in the pyramid, we have a smaller capacity on our hot tier DRAM. So obviously your data is gonna, your most important and most used data actually is going to live there. But that's become your bottleneck because you have traditionally you have to change pages around your whole stack in order to make sure your next page that you need is going to be in memory in order to be dealt with. By adding your Optane DC persistent memory, you increase that footprint. And then you can create decisions where you can use that as a regular memory or where you don't have the persistency across reboots, so service restarts, or you can actually make sure you have persistent access to that. So imagine that through your file system, you don't need to do context switch, paging in and out. Your data is directly accessed by your process. So SQL can actually change your memory page straight and store that directly into the memory bus. That's a groundbreaking understanding or how you actually use data within SQL. So you can choose actually which databases you're going to store on a persistent memory aspect. And then go down the road, you have a next tier of high performance, which you be your Optane DC solid state drive, which is another high velocity or high speed storage, but on a traditional block sense. So you still have the old semantics for read and write files through regular file stack, but still much faster than other block I/O. So you have the decision where to place your data and how to make sure your most important and high valuable data is fastly accessible and continually saved throughout reboots. So that's the key point where we are working with Microsoft and to extend the capabilities. So for instance, we have what's called hybrid buffer pool for SQL 2019, where you can use Optane DC persistent memory in order to increase the buffer pool for your SQL Server service. So imagine that all your clean pages can be on your Optane DC persistent memory, and that increases the whole buffer pool, the whole memory address that the SQL process can handle. So that's a really differentiation that Optane technology gives to Microsoft SQL. Anything else you want me to add, Jake?
No, that's perfect, because that's really why we're so excited about Intel Optane Data Center Persistent Memory. It's a memory innovation that is 10 years in the making. For some of us, it feels like it's 100 years. It's been dog years in many cases, but we're finally here, and we're so excited about it because we're able to deliver more VM instances. We're able to deliver up to 36 terabytes. We announced in partnership with Lenovo on an 8-socket system. So it's just incredible, the new opportunities that you can actually take advantage of when you start to think about new memory capabilities and new opportunities to optimize data stores. So we're going to talk about Intel Select Solutions. Alessandro and I have been actively involved, as you guys can imagine. But really, why did Intel begin this process of thinking, okay, you heard us talk about store and move and process, and move, store, and process, store, and move. Okay, but all of those technologies are sitting under a family of capabilities. And when you go to deploy them, you want them to work, and you want them to, you want to know that the technologies that you've purchased and you've committed to buy are delivering as promised. Well, our new CEO and our leadership team in DCG and NSG really felt it was critical to become customer obsessed and build predefined and verified solutions across a range of OEM partners with Microsoft. And so with Microsoft as our definition partner, we began this process to build highly optimized configurations for industry-leading technologies. Each of the select solutions that we build has a minimum of 100 Intel technologies included. It does have partner technologies from NVIDIA. It does have partner technologies from Samsung. It has partner technologies from Micron, from a host of players in the industry. But you can be certain that with an Intel Select solution that we verify, we test, and that the information provided to you about that solution has been tested and verified in the labs, and in about 98% of the cases is available to test in a lab if you bring your data to us. So what are the Intel Select solutions for analytics and for SQL, and why are we so excited? So we announced Microsoft SQL Server 16 and updated for 2nd gen. We have 5 select solutions for 1st gen. We will have at least 4 select solutions for 2nd gen. That will include Microsoft SQL Server, Microsoft SQL Server for Linux, both OLTP and data warehouse. We'll have support for Microsoft Azure Stack, and newly announced Microsoft Azure Stack HCI, formerly known as Windows Server. So we're really excited about the capabilities, the virtualization, security optimizations, as well as the container optimizations and database. And Alessandro talked to you about the PMFS or PMDK optimizations that we've been able to take advantage of in SQL. Let's go a little deeper into the numbers about what it actually means. So Alessandro, do you want to go into the benchmark that we ran and the huge benefits that we saw when we applied modern hardware to solve a data warehousing query problem?
Sure. So just comparing with an old 4-liter processor with SQL and Windows 2008, you see that we have a huge increase on query performance, or your terabytes query per hour, which will be your metric for data warehousing. But the good thing is we're not just showing a one or two technologies, we're showing the whole recipe, and that's what Intel Select solution gives you. So how to apply all those new technologies on new Xeon 2nd generation, Optane DC persistent memory, Optane SSDs, KLCs, Ethernet, in order to deliver this increase in performance. So it's not only the hardware or the software that you going to get that level of performance, but the combination of both. So you need the newest SQL version with our newest platforms in order to acquire these performance benefits. So that's basically our vision for Intel Select solution, to give you a roadmap on how to achieve that.
And with the transition, 24.8x performance gains against a 4-year-old legacy server hardware, it almost doesn't seem probable, but it's fact. And we actually have customers who are seeing greater numbers. This is the number that our legal department is most comfortable with. Having been a part of the team that launched the Intel Xeon Processor E5-2699, 3rd generation, that it was a great platform. This is an exponentially more performant platform, more secure platform, and a more flexible platform. Alessandro, talk about the queries and jump into what we did here on this benchmark a little bit.
So this is basically our, well, actually not ours, but Microsoft Data Warehouse Fast Track. So you can see how many queries per hour on the terabyte scale factor you could get. It's about 33,000 queries per hour. And we just jumped it, like you see, 24 times. Obviously, we have better CPU, but greater memory capacity, greater storage capacity. But without having the software and the hardware in order to achieve that, you won't be able to get even close to that performance. So that's basically a data warehouse fast track test that was done previously and compared to this our new generation. So basically the same benchmark testing that you can get from Microsoft, and our partners like Lenovo and other OEMs use the DWFT, or the Data Warehouse Fast Track from Microsoft, in order to get the Microsoft stamp that you can sustain that level of performance on data warehouse workloads.
And what's really exciting is we think that with future optimizations that we have coming, that unfortunately we're not able to announce today, that we'll be able to increase this performance this year. And then next year, we think there's another increase coming. So it's really exciting, and it's an incredible time for you as technologists, for you as leaders of data science in your organization. It's an incredible time for you to think through the modernization possibilities of the new data store, if you will, based on SQL. And we just think there's a tremendous amount of opportunity here. Let's talk about what multi-tenant virtualization consolidation means. For those listeners who are not aware, while I am a director today, at one point in my life, I was the product manager for virtualization for Intel, for our virtualization technologies known as VTX. And the numbers that Alessandro is going to share with you today are mind-boggling for me to think back from 2006 to today. It's amazing, it's exciting, it's what new architecture is all about, and it is why we modernize, and it's really what new data structures into the future should be about as we head into the new decade. So with that, Alessandro, talk a little bit about what we did with this multi-tenant virtualization consolidation benchmark. One of my favorite benchmarks in the world, by the way. I think it shows true performance. I like to say, if you can't put it on this track, I don't even know why you're in the industry. But anyway, that's a different webinar for a different day. But talk a little bit about what we did here to show true performance in the industry.
So what we've been looking is that we lack the density factor for servers, because we may have spare cores, but we don't have enough memory. So it's really an unbalanced solution where we don't have all our resources being fully utilized. So we took a base system with 768 gigabytes of pure DRAM and run our benchmark, and we could get about 22 Microsoft SQL VM instance. So think about not only on IaaS, but PaaS or containers, how much you can pack on a single node. And then you spread out that on your whole cluster. And if you look at, I need to store 300 VMs, that would be my top performance. You may actually save one node in your cluster just because you can pack more VMs per node. So we compared the performance with a new memory footprint where we had 192 gigs of DRAM and 1 terabyte of Intel DC persistent memory. So in this case, the system would see 1 terabyte of addressable memory. And with that new memory footprint, we can host up to 30 VMs on the same benchmark. So what gives us is we have 36% more VMs per node. So you have a denser node and a better utilized node. So you're not leaving either CPU cores idle. So you're actually monetizing. If you're a host provider, you're monetizing all your cores to your customers. And your price per VM goes down up to 27% because we save on your memory. So we put a cheaper, let's call, memory on your bus and more addressable space, and you can pack more VMs per node. And our VM is about 4 vCPUs and 32 gig of memory. So that was our VM block, but you can extrapolate that to any VM size that you have, and you could have that same amount of utilization, because what matters will be your relationship between vCPUs and cores, hyper-threaded cores, and how much memory per vCPU you're addressing. So that's the idea where you can have more workloads. Either it is IaaS, PaaS, or containers per node using Intel DC persistent memory with hypervisor, in this case, Hyper-V hypervisor. So that's basically
So,
what. So yeah, go ahead, Jake.
yeah, I was just going to say, so, that really completes the bulk of our presentation. We can go deep into any number of technologies that our listeners might want to discuss. So with that, Julie, I'd like to turn it back over to you, unless Alessandro has anything else he'd like to add. And I'd like to thank once again the PASS community for inviting us for this opportunity. It's just such an honor to be a part of the PASS community, and we hope to continue to work with the team here.
Thank you, Jake. I guess we have a poll. Eric, if you wanted to post the poll, we're kind of interested in what your primary role is. If you're a database administrator, a system administrator, cloud architect, or other. So if everybody could take just a few minutes or a minute, that'd be great to have that information. This was a really interesting presentation for me, Jake, because I'm in the process right now of trying to get quotes for really big servers for processing. Data warehouse,
Well,
yeah.
Well, Julie, anything we can do to help, I would love to, I love to be an active member of the PASS community because I started out my career as a system administrator and systems architect, and it's something I'm very passionate about to this day. So anything we can do to help, please don't hesitate to reach out.
Sure. So the poll's closed and it looks like 74% are database administrators, 5 are systems admins, and 5 are cloud architects, and we've got 16 other. We really appreciate everybody taking the time for this. This presentation has been recorded and it will be uploaded along with the slide decks to the Virtual DBA Chapter's website. So we should have that later today or tomorrow morning. So thank everybody for attending, and thank you, Jake and Alessandro, for the presentation. It was very helpful.
Thanks, Julie.
Thank you, Julie, so much.